Hey everyone, thanks for joining. Early birds dropping in. Great to see. Um, Usual stuff. We'll just give a couple of minutes for people to join in. And in the meantime, Mark, that's a lovely setup
Thank
with
you.
your background.
Yeah.
Is that for the
Yeah,
new job?
yeah. Sorry, what was that?
Is that for the new job?
No, this has always been my office for the last sort of 6 years. Yeah. But yeah, it's a nice little spot. I
I
can't
can see
take
the
any credit for
books.
any of the design. So yes, yeah, lots of books. Obviously, I have to do the
Nice.
subliminal marketing as well and put my books just on my shoulder.
Absolutely, it's quite an honor. You flaunt it like a medal or something. And of course, writing a book isn't that easy. And I've tried one and I failed. And I do know how much effort it takes to write one. And congratulations on your book. And I'm sure we're going to talk about it. But before
Mm,
we go,
mm.
we have 50 plus members who already joined. So thanks for dropping in. For those of you who already joined, thank you so much. Please feel free to say hi to our speaker Mark, and also, feel free to put in from which location you're joining from. It'll be great to know from where you're joining. And yeah, any message for us, that'll be great. So, with that, let's get started. And a very warm welcome again for all the early birds. And it's my great pleasure to introduce our speaker today, Mark 𝐕𝐴𝐺𝐻. Mark is a figure that many of you might already recognize, a master quality engineer, course director, and the author of influential books. How many of you have seen AI assisted testing and testing web API? So that both are excellent books that I've seen and heard people who have read the book, giving reviews about it. And with over a decade of experience in providing testing expertise, he brings invaluable insights to our session, especially about AI. Today Mark will address all the hype around AI. Is it real? Is it fake? Or a lot of those things to be discussed, especially around large language models, OpenAI's ChatGPT, GitHub Copilot and software testing. And, Mark is here to help us demystify and, get us through his journey of writing that book as well. And he also has an exciting giveaway for all of you who's joined today. So tune in, and I'll hand over the stage to Mark.
Nice one. Yeah. Well, yeah, thank you for having me today. It's a pleasure to be here and share a little bit about what I've been up to in the past 12 months, and talk a little bit about my passion project at the moment, which is AI and specifically large language models. So yeah, let's get into it. So yes, this talk is kind of it's interesting. It kind of came out as an offshoot of the work that I've been doing on my book, which I'll talk about in a minute. But interestingly, I think that the work I've done in this talk will probably end up in the book itself as well. So I wanted to start with a couple of bits. First of all, yeah, hello, my name is Mark. As Manoj says, I'm a quality engineer. I do a lot of teaching and writing around quality and testing. Been very much focused in test automation space and the use of tools. So when AI sort of kind of exploded further in the world, let alone in the testing community, I saw it as a natural transition to start sort of kind of exploring that. Yeah, today I want to talk a little bit more about not so much like the capabilities of these tools. I've seen a lot of webinars and blog posts, a lot of content talking about what you can do with large language models. And they're great. That's all fantastic. But I want to focus a little bit more about what it means for us as individuals, and what it means, like what we need to be focusing on. And I'm basically going to present to you a model that can help us kind of work towards using generative AI specifically successfully in our contexts. So yeah, if you want to get in touch with me as well, I'm predominantly on LinkedIn and it's still Twitter in my mind. So 2-Bit Tester on Twitter as well. So if you have any questions or follow up or want to learn more about AI or just speak to me in general about testing and quality, you can find me on those platforms as well. So yeah, let's get into it. So Yeah, as been mentioned, I'm currently in the process of writing my second book, which is known as AI assisted testing. My first book was testing web APIs. If you want to check that out. But this one has started as a very interesting project and a very different project to testing web APIs. So when I wrote my first book, I knew kind of what the general content was going to be. I'd been teaching how to test web APIs for quite a while. I'd been interacting with them quite a lot. Whereas with the AI assisted testing, how this came about was through a conversation of, this is an interesting topic to explore and pursue further. So the process has been very much like it has been as much about research as it has been about um, actually writing the book and constructing it, which is it's been really interesting, a really interesting challenge, and one that I've enjoyed a lot. If you are interested in the book, you can check it out at bit.ly/AI testing, and I'll mention some other bits and pieces at the end of the talk about it as well, about how you can get a copy. But the reason why I bring it up is because as I formed the book, as I put it together and I structured it, and I explored generative AI and how we could use it in various contexts, I ended up forming this model, as I say. And this model is, I think, can be quite useful for a way for us to understand how we move forward in terms of skilling ourselves, upskilling ourselves, and also reflecting on what our abilities are now and how we can improve them so that we can get value out of generative AI. So to do that, we're going to talk about three different aspects. So if we are to use generative AI or large language models, things like ChatGPT, Gemini, Claude, Llama, Mixtral, etc., all these types of models, if we are to use them, we want to use them in a way that gives us maximum value. And I mean that from the perspective of that these tools are providing value to us. So they're not slowing us down. They're not causing all the sort of typical issues that we have with tools. Because keep in mind, as fantastic and as amazing and as astonishing as these tools are, they are still tools. They are still software, and they are, we can run into the same challenges with them as we have done with any type of tooling. So we want to maximize value, but we also want to use them in a way that enhances and extends our abilities so that we are maximizing our value, so that we are providing value to our teams. So to do that, we're going to look at three different kind of aspects. First is mindset, technique, and context. So all three of these are essential parts that we require that, when worked together, can help us improve like our ability to provide value and to get value from these tools. If we're missing one of these, or if we're weaker in one of these areas, then there's the risk that we're not quite getting what we want from these tools. But also, there's the risk that issues such as like hallucinations might come through, or we may be sort of put off track or become sort of kind of consumed in maintenance efforts, perhaps with the generative AI, or perhaps with the sort of information and activities that come out of a consequence of working with these types of tools. So yeah, we're going to go through each of these in a bit more detail, and I'm going to sort of share some of the things that I'm covering in the book, but also kind of explain why I think that these three aspects are important. So let's begin with mindset, because I think that this is crucial. And this is something that's sort of very much informed with the work that I've done with automation in testing and a lot of the teaching I've done around testing, which is that to be successful with any sort of tool, we need the right sort of mindset. We need the right sort of attitude towards like when to use tools, when to identify that they are suitable and not suitable, understanding the limitations of the tools, understanding our own limitations, and then sort of combining those things and building a relationship together. So to kind of illustrate this, let's talk a little bit about, generative AI. What is it? As I say, lots of people have been giving webinars. There's a lot of blog posts, a lot of videos out there being shared. And, they're they do a fantastic job of kind of explaining the capabilities. But if you've not come across these, essentially the idea is that we provide some sort of type of prompt to a large language model. So it's some software or framework that's deployed onto a server somewhere. It might be actually running on your local machine, a neural net full of various parameters, which are kind of like nodes that all connect to each other. And what we do is we provide a prompt to these things. They process that information. And we have all sorts of types of different models out there. I mean, the list continues to grow, the sophistication continues to sort of climb, and these things are scaling further and further. But these are some of the sort of the common, most talked about sort of tools out there. But we provide a prompt to the large language model, and then it comes back with some sort of response. And we have this idea of multimodal models as well. So in these examples here, we provided some natural language or some code. We've got some code or natural language back, but we do have the ability to provide video and audio and images as well, and also to receive those types of formats out as well. So yeah, that's essentially from a sort of an end user's perspective. We put something in and we get something out. And it tends to be sort of like, it has the appearance of being generative in nature. And it also kind of almost feels like it's like you're talking to an individual. And I think that's one aspect of mindset that we need to be careful about. We don't want to anthropomorphize these tools. They don't think like us. They don't, they're not creative in the way that we are creative. I'll dig into that in a bit more in a minute. So it's worth talking very briefly as well, like about how does this work? How does this whole process work? Like, how do we get something where we send a prompt and say list 5 capital cities, and we get a response back with 5 capital cities? So what's interesting about this is that we all kind of have been experiencing this type of AI, this type of deep learning neural nets, sophisticated algorithm, like on our phones. So a fun little activity for you to do. You could do it now or you could do it later, but try like opening up something like Signal, WhatsApp, anything where you can basically get your keyboard up and start selecting the middle text. So you get that auto suggestion at the top of your keyboard, and it'll say something maybe like hello might be your first one, or it might be I, or hey, or guys. And we press that, and then those 3 sections update, and we get another suggested word, and we click that, and we get another suggested word, and we click that. And what we do is we do that fun little game when you're bored waiting for a train, a bus, a plane, or someone to get out of the bathroom, I don't know, or a changing room. But you see, you click through and you start generating this sentence. And the sentence initially sort of sounds like something that you would say, but then after a while it starts repeating itself, which is a bit odd in and of itself. But essentially what's happening is that when you're clicking that auto suggestion, you're selecting that sort of middle one, or maybe one to the left and the right. It's working in a similar way to how large language models work. Now, I say similar because what's going on in a large language model is much more sophisticated. There's been, I say new, but what's made large language models explode are technologies such as attention, but and they are fed with masses of data, much more data than your auto suggestion on your phone. But they kind of work in the same way in that they are predictive models. So you hear this term of parameters existing within a large language model. So you say, oh, this one has 10 billion parameters, this one has 2 billion, this one has 500 million. And what that means basically is that the way that a model is trained is it will take a body of text or some sort of body of information, and it will break it up into tokens. So in the context of like natural language, each word or maybe a collection of words is known as a token. So for every token, there is probably a parameter within the model. And as you train it, it learns basically based on a bunch of different attributes, what word should come after the next word, after the current word, sorry. So in the sort of example I've got here, we might have a model that has, let's say this is a model with parameter of count of 10. So very, very small model, utterly useless. But this is actually something I did using the autocorrect, auto suggestion on my phone. So I type in I am, and what it will do is those parameters and the kind of connections between them, the balances and weights between them will determine which is the next word that is most probable to be outputted. So for me, it said away and away for, because when I tested this out, I was traveling a lot. Then I select something like away for, and then it again goes through the parameters and starts looking at all of the different all the other, so it'll look for the token or the parameter away for, and it will look for the other parameters that are nearest to it and determine which of those are the most probable to go for next. So we've got the, and Christmas. So those are the strongest, most probable words to use next. So this is essentially how these large language models work, like I said, on a very sophisticated level. But what they're doing is they're using probability and relationships from one token or one word to other words or other tokens to determine what's the most likely thing to output. Now, I've gone into like a sort of LLM 101. Why do we care about this, and why does this connect back to mindset? So first of all, I think it's important that we understand that how these tools work, at least to a certain degree. Like, you know, there's a lot of sophisticated work going on in terms of how they're trained, how they're connected together. Typically, you know, if we're using something like ChatGPT, it's not one model, but there'll be multiple algorithms doing different things at different times. But I think it's important to raise this because we need to understand our relationship to them. They don't think like we think, and there's a lot of people sort of sharing that sort of information. But I think, again, it's important to understand they don't think like we do because they are probabilistic models. And that's not a criticism, that is just what they are. And that can be used to our advantage in ways, but also it helps us appreciate that the way in which we approach a problem, the way in which we respond to stimulus and input is going to be different to how these models do it. As I say, yeah, they are probability machines. And that's important as well in terms of like when it informs things like technique, context, which we'll get onto in a minute. So as I say, yeah, they're not likely to take our jobs in the near future, but they have the potential to change things. And again, it's appreciating that. I think that, you know, where I sit personally in the camp of all of this is I don't think that they're going to completely replace our jobs anytime soon, but nor do I think that these are things that should be ignored. We need healthy skepticism, but healthy engagement with these tools. Understanding what our capabilities are and understanding what the capabilities of these tools is critical, because we want to make sure that we are working with them in the right way. So with this in mind, I tend to think that, you know, that these types of tools are really useful for specific tasks, but they're not useful for everything. And I'll touch more on this as we go on. But I think it's important. Again, I think of it as like an area of effect. I'm in charge of the testing I do. I'm in charge of my little corner of quality within my team. And I should be setting the direction of what should be done in terms of tasks and actions. But I can use large language models to extend and enhance those abilities. If I don't, then the next person who comes along who is more comfortable with using these tools to enhance and extend, they're going to be more valuable to the team than I am. But equally, if I remove myself from the equation and we just rely on these large language models, then we run into issues around things like hallucinations. And as we touch on a little bit later with context, they're going to give you sort of generic, generalized answers to problems. So yeah, what we want to do is we want to focus on an approach in which we are maximizing the output from these tools rather than thinking about replication. Whenever I'm writing a prompt, whenever I'm engaging with these tools, I'm not thinking about how I would do it. I'm thinking about how do I get this tool to do it in the way that works best for it. And again, I'll touch on that again in technique. But yeah, this informs the mindset idea. We are the models, the large language models that we're engaging with, and what we do still have distinct attributes and behaviors and sort of value propositions. Combining the two is a great way of sort of improving how we work, but we're not looking to sort of get into that sort of debate or fall into that trap of being too reliant on the tools or not trusting them at all. So yeah, I talked a little bit about tasks. I said that how models can be useful in certain contexts. And I've always been influenced by a book called The Glass Cage by Nicholas Carr. I've been mentioning it quite a lot, probably more so than my own book. But there's a thing within the book that he talks about the idea of different problems that we have to face. There are heuristic-based problems and algorithmic-based problems. And I find this really interesting because heuristic-based problems tend to be more loosely defined, more complex situations to solve, and they require strong observation skills, and they require strong creativity skills. Think about, like, as testers, we have really strong critical and lateral thinking skills. They're fantastic for these sort of kind of heuristic-driven based problems. Then on the other side, we have the algorithmic based. So these are, tend to be much more bound, much more explicit. They can probably be described or explained to a certain degree. And it tends to be easier to determine whether or not you're going off course if you're following algorithmic steps. So, a way that we could combine this is in the heuristic space, it's exploratory testing. In the algorithmic place, it's much more test case driven or automating driven. And, a good healthy testing strategy, a holistic approach to quality combines the two. What's really interesting, though, is that, I just said exploratory testing and test cases, is that it doesn't mean that there aren't heuristic-based things going on when you're running a test case. So if you're executing your test case and you see something else going on that you respond to, that's the heuristic part, kicking in, your creativity, your observation skills. And the same within exploratory testing. If you are doing certain activities, there will be algorithmic tasks in there maybe to set things up. So yeah, these are sort of just some examples here of the ways in which we can kind of tackle the problem. So again, with mindset, it's understanding not just how the models work, but understand how we work. What are the challenges that we face? What are the problems that we're trying to kind of get past? Things like task analysis become really important because breaking things down into smaller things, what once might have been a heuristic-based problem, we start breaking it down, we start to see algorithmic problems in that space. We need test data setting up. We need to transform all of these testing notes into something that's a little bit easier to read and more distinct so we can give it to our project manager. Those sort of things can be where we start to use large language models. So yeah, having that eye for when we are in the heuristic space and when we're in an algorithmic space, and then knowing that LLMs work better in the algorithmic space than it might do in the creative space, heuristic space. So yeah, I mentioned this earlier. The way that I think of this is an area of effect model. So we as individuals, we lead the way with the work that we're doing, the testing we're doing. So we bring to the table our critical and lateral thinking skills, our observations, our ability to do task analysis, and basically our sense making of the world, of understanding the context and knowing and thinking about what's the next step to make. Then with large language models, what we're doing is we're enhancing and extending those abilities. So if we need to generate a lot of data or information within the context of a problem that we're facing, so I mentioned things like test data, for example, then you can use large language models. In the transformation space as well. So if we are wanting to convert reams of data and have it distilled and transformed into something that's more parsable, or into something that can give us like a summary, which kind of touches on translation as well, then these tools can help us with that. And I think what is interesting is in where the boundaries do blur is in the space of suggestion, because although they are probabilistic, and I don't think that we're in a situation right now where true creativity is coming out of these tools. The boundary or the scope is expanding. So if I provide some ideas of here's some risks I'm thinking of, and here's some context and some details, what would you suggest? It may return us some ideas that we've not considered. And again, as long as we apply that sort of healthy skepticism to those suggestions, oh, I like that one, don't like that one. That one's nonsense, it doesn't make any sense. We are still in the driving seat. We are still making those choices, but these tools are kind of helping us expand our views, shaking us up a little bit in our thinking. So we, kind of combating our own internal biases. So yeah, that's kind of like mindset in a nutshell. It's an appreciation of what these tools can do, what they can't do, being aware of the problem that you're facing, and then understanding whether it's a suitable problem to be solved with a large language model, or if it's a suitable tool to be solved by yourself, or a combination of both. And this is sort of a good example of this. So if we think about the testing lifecycle, there's different activities we might do. I think of this in a flow in the context of exploratory testing. So I will look at some information and I will come up with some ideas for testing. I may use a large language model to suggest some additional ideas, but I'm the one that's dictating what's going on. I'm just asking for further suggestions. I'm not asking it to tell me what to do. I'm making those choices and then asking for more feedback. In the creating and updating test data, I'm looking for ways in which I could generate that information quickly, or transform a bunch of data into, so say for example, someone's given me a requirements document and they've written it all out in given when then steps, but I need to put it into a SQL database. I could use a large language model to convert it quickly that way. Same with the setting up and executing tests. And then we come around as well, we observe what's happened. We've done our testing, we observe what's happening, we'll report it. I'm a huge fan of like making testing notes and mind maps and stuff, but they're really difficult to build into a concise report. We may use large language models to translate all our raw information into something more distilled. So yeah, I'm driving the testing. I'm doing the testing, I'm determining the direction, but I'm using these tools to kind of aid me. And I think that's the crucial aspect we have to keep in mind in mindset. Okay, let's talk about the next aspect, which is technique. I'm not going to go too into detail about this because I think this is something that's been talked about a lot. But if we want to maximize the output from these tools, then we need to develop techniques that allow us to maximize that output. So in the context of large language models, this is a lot to do with things like prompt engineering. So again, these large language models are probabilistic, and there are studies that have been carried out that work out ways in which you can send a prompt, phrases, structures to your prompts to allow you to get a more accurate response, a response that has less risk of hallucination, and basically allow us to get what we want out of these tools faster. And what's really interesting is that I think a lot of these sort of these tactics and these principles and the research that's shown is that the way that you prompt isn't exactly like, we see a lot of chatbots So we're kind of encouraged to talk to them like in a casual chatting manner, as if they're individuals. But actually, some of these techniques, things like the use of delimiters. So when we talk about the use of delimiters, you will say something like, I'm going to provide you, or like convert this HTML into a page object that is delimited by 3 backticks. And then I do 3 backticks in the prompt and I put the HTML in. And basically creating parameters there. That's almost like coding. It's not a natural language way to talk. You wouldn't ever say that to another human. So with prompt engineering, I think it's really interesting is because it's giving you skills and techniques and approaches that allow you to communicate to a model in a way that gets the best value out of it. And that is distinct and different to how you would talk to an individual. So again, I talk about this in the book quite a lot and give examples within the context of testing. But I was very much influenced by this deep learning course, the prompt engineering for developers. It's free to take. It only takes 20 minutes, half an hour, no more than an hour, I think, to watch all the way through. And it's got little examples and things like that. But it's brilliant. And these are not, by no means, not all of the principles and tactics. There's lots more to take on board. But I think what's crucial is that we are aware of the fact that we are interacting with a model that responds differently. So we need to develop those skills, like I say, maximize that value to strategically create prompts that give us what we want as quickly as possible. So bear with me a second, my controls are slightly over here. So I think this is really interesting because when it comes to technique as well, we need to also understand what type of model we're interacting with. So we've got things like ChatGPT, where we can have like a natural language conversation with them. But then we also have GitHub Copilot. And what's interesting is that these two systems that we can interact with are both based off the same GPT model, off the main foundational model that was trained, but then they were fine-tuned, and we'll come back to that in a minute. But they were fine-tuned to behave in different ways. Now, I think, again, in terms of technique, we have to think about what is the model that I'm interacting with? What is it skilled in, so to speak? What has it been tuned to do? And I think the best way to sort of kind of describe this is through the use of Copilot. So when I was exploring how to use GitHub Copilot and thinking about things like the prompting techniques that I was talking about earlier, and I was doing all sorts of interesting things where I was like, oh yeah, I'll put code comments in, and I'll be like, write a code comment and get it to output me the recommended code. So yeah, if you've not come across GitHub Copilot, the idea is it works within your IDE. It sees what you're typing, or it receives what you're typing, and then it will respond back with sort of recommendations, or try and autofill things for you. Now, what was interesting was when I started doing code comments, the responses I got back in terms of the code that it wanted to create was really variable. Some of it was useful, some of it was awful. And I was getting quite frustrated because I kept putting these code comments in, I wasn't getting what I wanted. And then something, I don't know, a light bulb clicked in my head, and I realized, well, this is a model that is tuned to react to code. So rather than using code comments to prompt it, what if I do unit tests? What if I start practicing TDD with Copilot? So rather than writing things like these code comments, I started writing unit tests out, and it would suggest, auto-suggest building some of the unit tests as well. But again, I'm in charge. Area of effect model. I'm choosing which unit tests I want to build to determine and design the thing that I want to build. And then what I would do is, once I'd finished my unit test, I would go into my class where I was building my production code. And because basically the prompt was now the code that sort of outlined how it expected a method to work, the production code that was written was much more accurate. It wasn't 100% code quality, A-OK, super perfect, but it was much more aligned, closely aligned with what I was asking for. So I think there's an interesting thing here again in the technique space of if you understand that you are interacting with a model that has been tuned to work with code, then really your prompting has to be within code. You need to almost speak its language, so to speak. And then the same with like when we're talking to things like the chatbots, we want to be using some of those other sort of engineering techniques that I was mentioning earlier. So yeah, technique is as much about understanding what it is that you're interacting with as it is the actual kind of the specific patterns that you can employ. Okay, so finally, context. So I think this is a crucial aspect as well. So we understand our relationship with these tools. We understand that they're helping us and enhancing us and extending us. We're developing these techniques to interact with this with these models to get the maximum value, but we're still hitting walls. We're still having problems. Perhaps, you know, the type of output that we're getting is not necessarily fully aligned with what it is. And what I've observed is I think that this comes down to context. So to give an example, if I sent something to ChatGPT and sent a prompt that said, create tests for a file upload feature, one of the interesting things about large language models is that they're always keen to answer. It's very rare, unless you're using specific prompt techniques to say, tell it to say, if you don't know the answer, say, I don't know. Is that it will respond. It will respond with anything. And it's kind of a garbage in, garbage out sort of situation. So if I say create tests for a file upload feature, it'll just give me a bunch of tests and suggestions, which, you know, depending on what I'm working on, some of these may be useful, some of these may be completely useless to me. And crucially, what's missing here is context, because I've just said for a file upload feature, I've given it a very generic, generalized request, and it's come back with a very generalized response. What I need to do is I need to infuse context into either the way that I'm requesting, the instructions that I'm sending to the model, or I need to infuse context into the model itself. So for example, if I take this delimiter tactic that I was talking about earlier, so here I'm building a prompt, I'm saying, also I'm using role-based instructions as well. You're an expert software tester, generate as many test cases as possible for the behavior delimited by 3 hashes. And then I drop my user story in there. I start to get more aligned, more accurate responses back. So you might necessarily need to read all of that user story, but tokens are an important aspect of the authorization process. And it picks up on that and it starts giving me things around, well, these are different ways in which you can manipulate your token. So yeah, infusing context is important, and employing techniques so that the model is more closely aligned, is more aware of our context, I think is important. So there's 2 ways in which we can do this. Well, 3 ways actually. So the first one is, as I say, being more mindful of the prompts that we are creating, and writing prompts where we pick parts of our context out. So we also need to be aware of our context. We need to select the right sort of information to infuse into our prompts so we can elicit better responses. But we can employ other techniques. So the first one is retrieval augmented generation. So the idea here is basically everything that I just talked about, but it's automated for us. So rather than us writing a prompt and then picking out information and copying it in, we build a framework where you can provide an input and then it will look at a corpus of data and combine those 2 things together. So what would typically happen is you would have, like say, a corpus of data. Vector databases get mentioned a lot here, but really it's just anywhere where there's some information that's stored in a standardized way that could be queried. That's really what we're talking about here. And I've seen some really good examples of this approach where they don't use things like vector databases. They just, you know, go and find the right SQL table and access that rather than trying to troll the whole database. So yeah, we have a user input corpus of data. We send our user input, type it into our little RAG framework. And what that will do is that will, first of all, take what we've written in our input and use that as a search criteria to look in the corpus of data to return back what they think is the most relevant documents. So it might go, oh, I found these user stories that are relevant, or I found these entries in a log file that are relevant. And that information comes back and it's added into a prompt, so a pre-generated prompt that we've created. So there'll be a section in the prompt that says, put the relevant data in here. So we do that. We also add our user input in. And what we've done is we've created a prompt similar to that one that I showed earlier with the tokens. We've sent our request, our instructions. We've now got relevant information about our context. We send it to a large language model, and then it will respond back to us. And the hope and the idea is that because what we've done is because we've provided some more context, relevant information in a way that's fast, we will get a more optimal response back. And then there's a lot of things we can do. We can experiment with what sort of data do we put in. We can determine how relevancy is determined. So we could choose different types of mathematical algorithms to determine relevancy. We can tweak our prompt as well, because as I say, it's a template prompt that you'll inject your user input and data into, so we can tweak that. And we can also experiment with different models. So there's a lot of flexibility here. Now, you might not necessarily be someone who's in charge of building one of these frameworks. But again, I think it's important to understand how they work, because if we are to use them, if we are to provide context into these requests and prompts, then understanding how these types of approaches work, I think is essential. The final one I wanted to talk about is fine-tuning. So fine-tuning is really interesting because what it's doing is it's taking a foundational model. So in OpenAI's context, it's a GPT model. With Google, it's the Gemma model. Llama as well from Meta, that's considered a foundational model. The Mixtral models, I believe, are foundational. I can't remember what Anthropic's would be. Anyway, the point is we have a broadly, generally tuned model. And what we could do is, as I said, inside it is lots of parameters that have weights and balances that connect one another to determine what's the next best word to put in. We can look to fine-tuning to start embedding in our own context. So what would happen if we fine-tuned it on all our test cases, all our user documentation, our code perhaps, anything that's got sort of some sort of explicit context written down. We can provide that in a data set. So there is a challenge here of taking things like test cases, taking things like requirements documents and arranging them in a data set that can be used for tuning. And what's really interesting in the fine-tuning space is that the focus tends to be more on the data set than it is the rest of the fine-tuning process. But what we could do is collate a load of information together. Then when we trigger off a fine-tuning process, what we do is inside a data set, we'll have the concept of an instruction and a response. And we may have some input data again as well. So like that delimited thing that I mentioned earlier. So we will send an instruction, we will send a prompt, and we'll build that all up. So using the instruction information from our data set. So think of an example like, how does the tax service API calculate interest rate? So that might be the instruction. The input data might be some examples of data that's inputted, and we send that to the large language model. Now, when you do this the first time, you send that prompt to the model, it doesn't know anything about your instructions or your context. I mean, it doesn't know anything because it doesn't think, but there's no bias towards your context within that model. So the model will take your prompt with your instruction. How do you work out the tax calculation? Here's some examples. It will come up with a response, and the response will probably be wrong. And what will happen is our fine-tuning setup will compare our expected output to our expected to the actual response, compare the two, and then create a thing called sentiment analysis. And that sentiment analysis will tweak the parameters inside the model. It will do the fine tuning. So what we're doing here is we're prompting the model and going, here's a question. What's your answer? No, your answer's not right. Tweak, tweak, tweak. Do it again. Do it again. Do it again. Do it again for thousands, tens of thousands, hundreds of thousands of times. And the idea is that as we go through this loop, we start tuning the model more towards our context. So we're not teaching the context, like the model isn't aware, the model isn't aware of our context, but it is certainly tuned in, like it's got bias towards our context. It might know it might be more tuned towards things like certain domain words or acronyms. From there, we then have a tuned model that we could then use in a chat setup. And what we would hope is that as we send prompts to it, then it responds in a way that is much more aligned. So yeah, two different ways in which we can approach context. And both approaches have pros and cons. I'm not going to read through all of this, but I will share the slides. And again, this is all within my book, so you can look at it there. But essentially, these are two distinct approaches with varying levels of sort of learning curves and resource costs as well. But what's really interesting is you can combine the two. So you remember, if I went back to my diagram of how we do retrieval to generation, we send our extended prompt to a model. We could use a fine-tuned model, so we could tune it with all of our context and then put it into a RAG setup to sort of double that up. Obviously, it's much more expensive and there's a lot more things that could go wrong, but potential is there. So to wrap things up, in summary, I think that success with the LLMs, I haven't updated this slide. It depends on three factors. So an earlier iteration of this talk, I talked about it as task identification, prompting, and context. But actually, I've changed this now. The three factors are mindset, technique, and context. So task identification is part of the mindset, but it's as much about our relationship and our understanding of how these tools work and how we bring them into our process. Prompting is part of technique, but also understanding our models, and then context. Say LLMs won't replace our work, but they will appear in more specific tasks. And I think this is where we're going to see it. So, AI in testing has been around for ages. Visual AI has been around for a long time, and screenshot comparison, visual comparison tools have existed for a while, and they're really useful in that space. I think what we will start to see is other areas of testing, other areas of software development, the whole Copilot thing. It's not replacing the whole of software development, but it is helping with specific tasks. So things, when we're talking about techniques, having an awareness of things like prompting, prompt engineering, and understanding what it is you're prompting is important. And also maximizing value requires exposure to our context. So it's all well and good to write the best prompt possible, but if you're not giving it that additional information, it's not going to be able to, it's going to reduce the chances of a useful response. We have to keep that in mind as well. So I think we have a little bit of time left, so I'm open to any questions. But yeah, if you enjoyed the book, be sure to check it out. And if not, come grab me on Twitter or LinkedIn and say hi. Thank you.
Thanks, Mark. So it was a wonderful session with lots of tech insights. I'm assuming a lot of folks enjoyed as well. And to surprise, I've actually seen countries that have not joined earlier have joined this time for your session, Mark. So yeah, I can see comments like fantastic dialogue, many gems. Thanks for sharing. So yeah, there you go. So people love that sessions.
Lovely. I'm glad it was useful.
Absolutely. People joining in from Florida, Uruguay, Pittsburgh, Ukraine, India, Oh, different parts of the world. Thank you. Thanks for all the sessions. So yeah, I've actually seen quite a few people raising their hands. So unfortunately, we would not be able to promote you up on the stage or unmute you and ask question. Instead, if you have a question, I request you to please post it in the Q&A section, and we will take it one by one. All right, let me pull up the questions. We have quite a few. Wow. All right. So, Mariana Diaz, in regards to learning how to get the most out of LLM instead of wanting the machine to think like we do, from your experience, do you think we are improving and we are in the right direction to smartly use these tools, or do you think we haven't even started?
Oh, good question. So I think first thing is I would bring it back to the point I was making earlier, which is that large language models are software, sophisticated software, but it is software. And I think that some of the stuff that I talked about in the mindset aspect, especially, I've been talking about this for years. Like, you could replace large language models with like the ability to use end-to-end testing tools, or API testing tools, or screenshotting tools. I think that, yeah, that there is an aspect of we as an industry have to get better at understanding that it's problems first, tools second. It can be difficult to do that, especially when you're kind of in the mix and you're doing the work. But I think that that's always been a mantra that I've kind of kept in my head about problems over tools. If you understand your problem space first, then the tooling selection becomes a lot easier. As you know, in terms of like how it applies to the industry as a whole, it depends on the context. I always sort of see our industry almost as like an elastic band. Some of us are, and we're all in different spaces at different times. I currently work in an enterprise setup, but we are doing some very interesting things. So we're perhaps more closer to the cutting edge than perhaps an enterprise company that's first moving into its agile transformation. So I think that, yeah, there's some people, some individuals, some contexts, some organizations, they understand that idea of problems first, tools second. Some others don't. And I think it also comes down to experience as well, because some have been burnt by tools. Like, I say these things from years of making many, many mistakes. If you saw my first ever script written in Python, you'd probably ask me to leave. But yeah, it comes down to experience as well. But this is why I wrote the book. This is why I talk about these things. This is why we have a lot of people in the community talking about these things, because I think we have to keep banging the drum. We have to keep in mind the fact that the conversation around large language models is as much about us and what we do as it is what they do.
Wonderful. Thanks, Mark. There's lots of insights there. So, Mark, I think this question is in general. I believe this is something that might be going on in everyone's mind for someone who wanted to get started with AI. There's lots of tech stuff that you just explained on how RAG works and how it goes. The input is gone in, and then generates, and then we get an output, and then prompt engineering, all of it. But if you want to just give a a bird's eye view about if someone who's new want to get started with the AI stuff, what are the things to look for? And if we want to put out like a roadmap, what it could be?
A roadmap in terms of your own sort of learning and development? Is that what you mean?
Yeah, learning. Yeah.
Yeah.
I can easily say that's what the book is written for, of course.
Yeah, buy my book.
No,
but it's an interesting question to ask, because before I started the book, I was new to a lot of this.
absolutely.
I was in a position where, like, having I'd read around the topic a little bit anyway. So a great book, AIQ, I would recommend, because that just talks about the maths and the history of the maths around like most of the algorithms that we tend to use. And what's really interesting is a lot of the algorithms that exist within AI, they've been around since the 50s and the 60s. It's the compute that's caught up. And that's why we're seeing the leaps that we're seeing. And then, being comfortable with scripting languages. I'm not saying you need to learn to code to be comfortable with AI tools, but that gives you, again, that little leg up. I'd say the biggest thing though is and one of the reasons why large language models I think have become massive popular is the open source community around it is fantastic. So it's a very generous, very giving space. And what's really interesting as well is that there are people within that community who are trying to build tools that kind of democratize access to AI. So the tools that I use in the book that I can recommend having a play with are things like Axolotl. So that whole fine tuning thing that I talked about, I used a tool called Axolotl, and all I needed to do was configure a YAML file. I needed some data, which I could find on a site called Hugging Face, which is a great open source community around AI. I find a data set, find a model, I put them in the YAML file, I spin up, a cloud cluster or something, or run it on my machine if I've got GPU. I run the YAML file, and that's it. It's done the work for me. So there's always this feeling like, oh, it's a massive barrier to achieve, but I think that barrier is massively dropped. Is really dropped because the open source community is designing these tools and these means to access and work with these tools quickly. Pinecone as well. So on the RAG side, I use Pinecone vector databases within the book, because they've built this whole framework, whole RAG framework, where literally all you do is you open up an account, download a command line interface, provide a few API keys, and again, here's my data, here's my text files, process them, right, let me start requesting. So yeah, I think you've got to get into the experimental mindset, got to have a play with these things. I think that's crucial as well.
Absolutely. It's a good way to put it, Mark. Thank you so much. There's a question from Taras Lushak. Mark, do you use 𝐌𝐚𝐫 from LangChain in an AI automated testing? And if yes, how? I think before answering that, I've actually tried LangChain, and I also believe in one of our product suites at Lambda Test, we are using LangChain, and Lambda Test has AI features. And for those of you who don't know, type it out, AI features Lambda Test, and you will get a lot of those for you, and especially around root cause analysis of your tests, flaky tests, and all of it. So yeah, LangChain is very interesting. So Mark, have you encountered any experiments or LangChain specifically?
So I had a look at LangChain, and it's clearly a powerful platform and set of tools to use. So if you've not come across LangChain before, the way I kind of think of it, it's like Zapier, but for AI. It's a means to connect things like models, vector databases, and other information together. That is a very generalized thing, but it's that way, in a way that doesn't require you to go read a book about how to use scikit in Python or PyTorch and write it all out yourself. The reason why I didn't use it in the book was because it was purely like a kind of teaching thing. In the middle part of the book, I talk about like how we can use AI to support our automated testing. So I give a lot of examples of how I could prompt to build like page objects in Java. So I didn't want to bring Python in as another language, because then my reader has to know Python and Java at the same time, and that limits things. And as I said, like tools like Axolotl, tools like the Pinecone, I wish I could remember what it was called now, but it was designed by Pinecone. But those sort of tools are a great starter for 10. I think if you're looking for that next step, then LangChain becomes more sort of relevant. Then I see a lot of sort of debates in the community as well, like how much do you need that versus rolling your own as well. So there's that kind of factor as well.
Yep. All right, the next one, and maybe the last one for today, from Federico. In your opinion, how much more testers will need to be embedded in development process in ML projects? For instance, to understand and verify the quality of data pipeline for training or fine-tuning, or to test the RAG pipeline, etc.
I think it depends on the demand of. So yeah, I think we do need more testers involved in this process. And yeah, I want to be clear, like a lot of what I've been talking about today is what I sort of see as the applied space of AI. And that's the space that I'm very much I feel confident in. But I think that, yeah, the testing AI space, I think still very much, it's very fuzzy, it's still very undefined. But it's personally, it's something that I'm sort of interested in exploring further as well. So I think we do need more people in that space, but I think it's less testers and more quality engineers. And the reason why I make that distinction is because I think it's essential to be in those early conversations around data sets, data set creations and scraping and labeling and parameter choices and feature choices and things like that. So talking about how we're going to structure that sort of information, where are we going to get it from, the ethics of that sort of thing, what is it that we want, what are the end goals of this as well. Like a really crucial aspect that I'm going to call out Carlos Kidman on this one, because when I was writing the final chapter of the book, I was really struggling with the final chapter. So I knew how to technically fine tune a thing, but I was all over the place. And it wasn't until I spoke to him that he was like, well, what are you trying to achieve? Just asking that one question, which is a classic tester quality engineering question, helped frame things. So I think we are going to need more people in that space, but those people are going to need to be skilled, not just in technical aspects of like data pipelines and training and inference and ML ops and monitoring and stuff like that, but they need to be as much rooted in the sort of, where does this thing sit in within society as well? What is the impact of a model of this? What are the ethics for us as individuals, society, our organization, that sort of thing? So, but it's all rooted in is how much more a company's going to take on these types of tools as well. Because I think we're about to probably hit into that Gartner trough of disillusionment as well. So we'll probably see these projects trail off, but it'd be interesting to see what bubbles up afterwards.
Cool. Thanks, Mark. I hope that answered your question, Federico. And yeah, we're almost there. And before we close for today's session, Mark, do you want to announce the giveaway?
Yeah. So as thanks for attending, we are able to give out a discount code for the book, which I believe will be sending the email after this session. So you can use that discount to get, I think it's 35% off the book. That said, this weekend, as it is Memorial Day in the States and my publisher is in the States, it's 50% off from Saturday to Monday, I believe. So if you want to catch it now, catch it here when it's cheaper, but if not, that discount card's there. And feel free to share it with our friends if you want. Also, it's an opportunity. The book's not totally finished yet. So it's in early access. So you have the freedom to write comments and ask questions, and they come to me, they come in my inbox, and I do read every one of them, and I will factor feedback in to improve the book as well.
It's amazing. It's amazing. Thanks, Mark. That's so generous, and I can see people getting excited about it. And more discounts are very helpful. That especially for a book that's in early access, and you're able to give feedbacks and get directly answered from you. So again, yeah, for those of you who are not able to get your questions asked, or if you have anything more, so yeah, go ahead, buy the book, ask any questions. I'm sure Mark will be able to kickstart your AI journey. With that, thank you everyone for joining us, and thanks, Mark, for the wonderful session and for the giveaway for our audience from the Lambda Test Voice of Community. It was very grateful to have you with us today, talking about the AI assisted testing. Thank you very much, and take care until we see you in the next month edition with another exciting story. Thank you all.
Bye.